Our planet is full of wonders, some common and familiar like rain and sunshine, and others so rare they almost seem like magic. From glowing orbs of light that defy explanation to frozen petals blooming on the sea, Earth occasionally reveals phenomena that are as mysterious as they are breathtaking. Welcome to Third World View, where we explore the beauty, complexity, and mysteries of our planet. In today's episode, we're diving into the fascinating world of rare weather phenomena. Together, we'll uncover the science and stories behind three extraordinary events: the enigmatic ball lightning, the delicate frost flowers, and the mesmerizing fire rainbow. What causes these phenomena, and why are they so rare? Let's explore. Imagine a summer storm. The sky, a tumultuous canvas of gray and charcoal, is ripped apart by forks of brilliant lightning. The air crackles with energy. Rain lashes down, driven by winds that howl and moan. And then, you see it. A glowing sphere, seemingly suspended between the sky and the earth, pulsating with an otherworldly light. This is ball lightning, a phenomenon as captivating as it is elusive. For centuries, tales of ball lightning have been woven into folklore and myth. Sailors whispered of glowing orbs dancing on the masts of ships during tempests, while villagers spoke in hushed tones of fiery spheres that appeared without warning in their homes. For much of that time, the very existence of ball lightning was dismissed by scientists as mere superstition. But eyewitness accounts persisted, many from credible observers who reported seeing ball lightning with their own eyes. These weren't fleeting glimpses. Some encounters lasted for seconds, even minutes, with the glowing orbs moving through the air, hovering, or even bouncing off objects. The descriptions, though varied, shared a common thread: a sense of awe, of witnessing something truly extraordinary. The scientific community, once skeptical, began to take notice. The sheer number of reports, coupled with the sincerity of the witnesses, made it clear that something unusual was happening. But what? What could possibly explain these luminous spheres that seemed to defy the laws of nature? The challenge for scientists lay in the unpredictable and fleeting nature of ball lightning. It appears without warning, often during thunderstorms, but not always. It lasts for a few seconds, sometimes longer, before vanishing abruptly, sometimes silently, sometimes with a deafening explosion. This unpredictability makes it nearly impossible to study in the wild. Despite these challenges, scientists have made some progress in unraveling the mystery of ball lightning. One promising area of research focuses on the role of silicon in the phenomenon. The theory suggests that when lightning strikes the ground, it can vaporize silica in the soil. This vaporized silica, when combined with oxygen in the air, can form nanoparticles of silicon dioxide, which then aggregate into a glowing sphere. This theory is supported by laboratory experiments where researchers have been able to create ball lightning-like effects by passing high-voltage electricity through silicon wafers. These experiments have produced glowing spheres that exhibit some of the characteristics of ball lightning, such as movement and a short lifespan. Another theory proposes that ball lightning is a type of plasma, a superheated state of matter where electrons are stripped from atoms, creating an electrically charged gas. This plasma, confined by its own magnetic field, could potentially explain the ball lightning's spherical shape and its ability to move erratically. The plasma theory is supported by the fact that ball lightning has been observed to interact with electromagnetic fields. Despite these advances, ball lightning remains an enigma, a reminder that even in the 21st century, there are still mysteries in the natural world that we have yet to unravel. So the next time you find yourself caught in a thunderstorm, take a moment to appreciate the power and the mystery of the storm. Imagine a world cloaked in silence, where the air itself seems to hold its breath. A thin layer of ice, crystal clear, covers a tranquil lake, mirroring the pale hues of the pre-dawn sky. And then, as if by magic, intricate formations begin to emerge on the icy surface, their delicate beauty a stark contrast to the harsh, frozen landscape. These are frost flowers, ephemeral masterpieces sculpted by nature's patient hand. Unlike their botanical counterparts, frost flowers are not plants at all, but rather intricate ice crystals that form under very specific conditions. This delicate dance of nature occurs when the air temperature is well below freezing, but the ice itself is warmer, typically because it is in contact with warmer water beneath. This temperature difference creates a gradient, with the warmer ice sublimating or transitioning directly from a solid to a gas. This water vapor then rises, meeting the frigid air above. As the water vapor cools rapidly, it reaches its dew point, the temperature at which it can no longer hold its gaseous form. But instead of condensing into water droplets, the extreme cold forces the water molecules to crystallize directly from the vapor phase, a process known as deposition. The ice crystals grow outward from imperfections on the ice surface, creating delicate, feathery structures that resemble petals or feathers. Each frost flower is unique, its shape influenced by a complex interplay of factors, including air temperature, humidity, wind speed, and the texture of the ice surface. Some resemble delicate ferns, their fronds unfurling in intricate patterns. Others resemble delicate sea anemones, their tentacles reaching skyward. Still others form intricate rosettes, their delicate petals arranged in perfect symmetry. The ephemeral nature of frost flowers only adds to their allure. They are fleeting masterpieces, often lasting only a few hours before the rising sun melts them away. A slight breeze, a change in temperature, or even the warmth of the sun's rays can shatter their delicate structures, returning them to the icy surface from which they arose. Though most commonly found on lake and sea ice, frost flowers have also been observed on land, typically on thin ice that forms over moist soil. In these environments, the frost flowers often take on a different appearance, resembling delicate needles or hairs rather than flowers. The beauty of frost flowers lies not just in their delicate forms, but also in the science behind their formation. They are a testament to the intricate and often unexpected ways in which water, temperature, and atmospheric conditions interact to create beauty in the natural world. Chapter 3. Fire Rainbows, a spectrum of ice and light. Imagine a sky ablaze with color, a vibrant arc of spectral hues painted across the vast canvas of the heavens. This isn't a rainbow in the traditional sense, born from the interplay of sunlight and raindrops. This is a fire rainbow, a rarer, more elusive phenomenon known scientifically as a circumhorizontal arc. It's a spectacle that transforms the sky into a breathtaking display of nature's artistry. Despite their fiery moniker, fire rainbows have no connection to actual flames. Their creation lies not in the heat of combustion, but in the cold beauty of ice crystals, meticulously arranged within wispy cirrus clouds that sail at altitudes exceeding 20,000 feet. These clouds, composed entirely of ice crystals, become the canvas upon which the sun paints its vibrant masterpiece. For a fire rainbow to ignite the sky, a precise set of conditions must align. The sun must ascend to an elevation of at least 58 degrees above the horizon, its rays striking the ice crystals at a specific angle. These crystals, often hexagonal in shape, act as prisms, refracting and dispersing sunlight into its constituent colors. As sunlight enters an ice crystal, it's bent, or refracted, twice, once upon entering and again upon exiting. This double refraction, if occurring at the precise angle, separates the sunlight into its different wavelengths, each corresponding to a specific color. The result is a dazzling spectrum of hues, a celestial mosaic of reds, oranges, yellows, greens, blues, indigos, and violets. Adding to their rarity, fire rainbows are confined to specific latitudes. They're most commonly observed in regions closer to the equator, where the sun reaches a sufficiently high angle in the sky. In these regions, during the summer months when cirrus clouds are more prevalent, the conditions ripen for the fiery spectacle to unfold. The ephemeral nature of fire rainbows only amplifies their allure. As with many atmospheric phenomena, their appearance is fleeting, often lasting for less than an hour. The slightest shift in the sun's position, a change in the cloud's composition, or a whisper of wind disrupting the ice crystal's delicate alignment can cause the fiery arc to vanish as quickly as it appeared. Observing a fire rainbow is a privilege, a fleeting glimpse into the exquisite beauty that emerges when atmospheric conditions converge in perfect harmony. Rare weather phenomena like ball lightning, frost flowers, and fire rainbows show us the incredible complexity and beauty of our planet. They inspire curiosity and remind us how much there still is to discover about the world around us. Thank you for joining us on Third World View. If you enjoyed this exploration of Earth's beauty and complexity, please like this video, share it with others, and subscribe to our channel for more fascinating journeys into the natural world. Have you ever witnessed one of these rare events? Or do you know of others we should explore? Share your stories in the comments below. Until next time, keep your eyes on the skies and your heart open to the wonders of the earth.